Okay, now we're going to change the game a little bit here and start looking at equations that don't have nice clean solutions. Notice you've got a square on the left and the right is not quite a square, but we're going to force the square root, and we're going to have x equals plus or minus the square root of 30, both of which, when squared, give you a positive 30. On this next problem, again, you've got x plus 5 quantity squared. You want to undo that squared quantity by square rooting each side. So now you're going to have x plus 5 equals plus or minus root 11. And don't forget that plus or minus sign. Now, we want the x by itself. We want to subtract 5 on each side. And there's an understood rule that whenever there's a plus or minus involved, that negative 5 will go to the left of that plus or minus, so that you have negative 5 plus or minus root 11. Now, most math teachers are perfectly fine if you write your answer in that form. However, I do want to mention that Alex is going to ask you, and some teachers will ask you, to write this as negative 5 plus root 11 and negative 5 minus root 11, which actually is kind of good because it emphasizes the fact that there really are two solutions to this equation. On this next problem, which is almost the same thing, we have a 12 on the right. When we go to square root that 12, that 12 will break down. So we're going to have x minus 3 equals plus or minus the square root of 12. And I'm going to do a little sideways factor tree here. That 12 will break down into a 4 times 3, and the 4 will break down into a pair of 3's, or a single 3, and that pair of 2's will come out front. And we're going to have x minus 3 equals plus or minus 2 root 3. And then adding the 3 to both sides, writing it to the left of the plus or minus sign, we have 3 plus or minus 2 root 3. Okay, this next problem has a plus 7 on the left-hand side, and just like with our square root equations, we had to isolate the radical on the left side of the equation. Here too, we need to isolate the square on both sides of the equation before we square root. So we're going to subtract 7 on both sides, giving us 5x minus 2 quantity squared equals 6. And then we're going to undo that square on both sides by square rooting each side of the equation. That will give us 5x minus 2 equals plus or minus, don't forget that, root 6. Then we're going to add 2 to each side of the equation, which leaves us 5x equals 2 plus or minus root 6. And then when we go to divide each side by 5, it does get a little bit messy there. This is going to be written as x equals 2 plus or minus root 6 all over 5. And I know we look at this answer and say, wow, that's messy, but quite honestly, this is what answers to quadratic equations typically look like. Now, this is checkable. I know you look at this going, no way do I want to substitute that back into the original problem. But notice when you substitute it back in, the first thing you would do is multiply by 5, which cancels out the division by 5. You would then subtract the 2, which says goodbye to that 2 out in front, and you're just left with a plus or minus root 6, both of which square to give you 6, plus 7 is 13. So they do check out, and they are valid solutions to this equation. Now, let's do one more problem here, and let me get that centered on the screen. Notice this time we've got a minus 5 on the left as well as the 7. So we want to add 5 to both sides. We're trying to get that quantity squared isolated by itself. That's going to give us 7 times the 3x plus 1 quantity squared equals 3. And then we're going to divide each side by 7. And unfortunately, 3 is not a multiple of 7. So we're going to have a fraction on the right-hand side. 3x plus 1 squared equals 3/7. But that's okay. Just let the right be whatever it's going to be. Our goal is to solve for x. So now we're going to square root both sides. On the left, we just have 3x plus 1, and on the right, don't forget that plus or minus symbol. I know we're focusing on this plus or minus root 3/7, which is not good news. I'm going to move that up a little bit now. It's not good news because we're not allowed to have a radical in the denominator. So I'm going to rationalize the denominator, multiplying by root 7 over root 7. I'm going to leave the left side as it was, giving us plus or minus root 21 over root 49, which is the whole number 7. I'm now going to subtract 1 on each side. We're trying to get that x by itself on the left, and that gives us 3x equals -1 on the right, plus or minus root 21 over 7. And notice it's not all over 7 as the last problem, but typically we do like it to be all over 7. So I'm going to rewrite that as a -1 over 1. Remind ourselves we could write that as a -7 over 7. And now actually write it that way over the common denominator of 7. -7 plus or minus root 21 over 7. Now, when it comes to dividing off the 3, you could write a big divide by 3 on the right, but then you'd have to say, ooh, I'm dividing by a 3 over 1, and that would mean multiplying by the reciprocal 1/3. And that is basically the same thing as multiplying by a third to undo the 3 on the left. Now we have final answer, x equals, the 7 times 3 in the denominator becomes 21, and we're going to have -7 plus or minus root 21 all over 1. Now be careful, you cannot cancel the 21s. First off, because the one up in the numerator is inside of a radical. And you can't also cancel the 7 and the 21 because 7 is not a factor of the numerator. That plus or minus sign up in the numerator says that 7 is not free to be canceled with. Remember that you can only factor and cancel when you've got fractions involved.